Geneticist George Church is not a contented man.
It just seemed like there were lots of things missing from the world.
That discontent drove Church to create the things that were missing. The technology he invented is powering a major revolution in medicine and may even alter life itself.
This idea kept haunting me that everybody should be able to get their own genome, and it should be affordable so that it really was kind of a birthright.
Church's journey into science began at Phillips High School Academy in Andover, Massachusetts.
It's like a whole new rainbow opened up for me, and the world changed from black and white to color.
He gobbled up all the opportunities that school offered, including working in research labs. He zoomed through a Duke University bachelor's degree in 2 years, but got into trouble when he went to Duke's graduate school. In 1977,
I flunked out of the graduate program. I was so excited about research I was doing in X-ray crystallography that I just didn't want to go to courses anymore.
However, Harvard immediately accepted him. And in 1986, he joined the Harvard Medical School faculty, where he has been ever since. His graduate work in X-ray crystallography taught him an important lesson.
I was exposed to the one field of biology where they actually had automation and computers. And I sort of felt like, why doesn't the rest of biology have automation and computers?
Knowing the sequence of the billions of letters in the genome was not enough. In order to read the genome, you needed to be able to interpret what the letters spell. Church wrote groundbreaking computer programs to make sense of DNA sequences.
What I've done over the years is to think of every possible way to bring down the cost of reading and writing genomes.
The first sequence of a human genome, announced in 2000, took 10 years and cost $3 billion. By miniaturizing the entire process onto chips and a series of other innovations, Church made it possible to sequence genomes quickly at a price plunging down toward $1,000. Church's department chair, Cliff Tabin, says that these technologies changed everything.
Nobody, absolutely nobody, is more responsible for our ability to sequence DNA and synthesize DNA and manipulate DNA at the level that we can now than George Church. Just absolutely no one else. It's not just that he's found a way to do it quicker. You know, he's totally changed the whole approach of sequencing DNA. And he's also been a pioneer in thinking about what the societal implications of this are. He's responsible for something called the Personal Genome Project.
The point of the Personal Genome Project is to help research connect genes, environments, and traits.
The project is going to sequence the genomes of 100,000 people and make their sequences and medical histories available to researchers.
It really isn't intended to change our views of privacy, but it may do that. Genomes and your medical records are still in flux. We don't know whether you get more benefit from sharing it or from protecting it.
Church is pioneering another step in the genomics revolution, synthetic biology. Someday, scientists will write the solutions to medical and environmental problems in the language of DNA. Engineers will develop biological computers and design new organisms that could clean up the environment or manufacture brand new materials.
Biology is better than anything at making atomically precise molecular objects. So you can imagine everything, clothing, perfume, computers, can be made as cheaply as biological things are made.
Several companies are already benefiting from Church's innovations. He has also mentored hundreds of students and postdocs, populating these companies and guiding them with this advice.
You don't have to accept things the way they are. The more radically you reimagine them and think about it in a lot of different ways, then you might stumble upon, or indeed even engineer in a fairly rational way, a completely new way of doing things.
The 2011 Bauer Award and Prize for Achievement in Science was given to George Church, for innovative and creative contributions to genomic science, including the development of DNA sequencing technologies, as well as for his subsequent efforts to promote personal genomics and synthetic biology.